The purpose of this video is to look at how we can use Haiti's vast solar input to power her infrastructure. We start by building ultralight railroads, where vehicles suspended from underneath the rails use a tenth the energy of oil-powered infrastructure. These can be built in congested areas without impacting current traffic. Here's an example of how we design networks. So from the blue crosshair, everything in green can be reached in 10 minutes, yellow in 20, and red in 30, in a combination of riding and walking. My name is Bill James. With a group of West Point classmates that studied nuclear engineering together, we've pulled together a team with the mission of displacing 70% of oil-powered urban transportation by 2020. In the 4-year period between 1865 and 1869, private enterprise funded the construction of the transcontinental railroads, cutting the cost of a ticket from New York to San Francisco from $1,000 to $67. Freight rail averages 480 ton-miles per gallon by eliminating the repetitive start-stops. J-pods are ultralight vehicles, so we take out the parasitic mass, we take out the repetitive start-stops, and now we can move people, cargo, and trash in a city using a tenth the energy of cars, trains, and buses. The change from 56 cents a mile to operate a car to 6 cents a mile to operate a J-pod, the saving of $600 billion a year in imported oil, pays for the $5 trillion in networks every 8 to 20 years. Like the building of railroads and the internet, impossibly large infrastructure projects can convert costs into profits. By deploying solar collectors over the top of the rails, we gather 5,000 to 30,000 vehicle miles of power per mile of rail per day. So we can power urban transportation within a solar energy budget and make the networks durable against a single point of failure of a blackout. We also have a version of this thing called Rescue Rail that can be thrown up at the rate that the transcontinental railroads were built, of about 3 to 10 miles per day per crew, to deploy out for special events or to mitigate the consequences and reduce the energy required to recover from disasters. Our team has considerable experience in leadership, manufacturing, technology, logistics, and operations. As examples, I founded ASI Datamite, which does statistical process controls for controlling manufacturing operations. I wrote the software that Twin City Business Monthly listed as the best new high-tech product of the year for the region. In 1998, Wiley published a book called Desktop Hosting about this approach to software. We have built robots and a small demonstration unit that we've put thousands of people through, and they get out of it and they go, we're going to be the Jetsons, because you get in it, you touch home, mall, school, or work, it goes up and down the rail and stops at an appropriate location. We've put together the mechanical drawings for the overhead truss assemblies and looked at the footings and the other aspects that we have to do for the civil engineering. Our team has built the power system for the infrastructure. Here's an example at Plantronics headquarters, the Bluetooth earpiece company in Santa Cruz, California, designed by Ron Swenson. We've also designed a chemical storage system. Nature's low-work solution for storing and distributing solar energy is not electricity but chemistry: food, wood, coal, oil, natural gas. If we start immediately, Haiti can power her infrastructure within a solar budget by 2016.